Hello and welcome to another video. In this video, we're going to continue talking about database concepts. So as we learned, a database is a collection of data, and it's specifically organized for rapid searching and retrieval of that data by or through a computer. A simple form of a database is just a file. Another example would be an Excel spreadsheet. A database is usually created to support some kind of application or system. A database management system is the collection of those related files or tables. And again, these files or tables, this collection of data is going to serve a common purpose or serve or support an application. Now, a database management system it's going to have relationships that are governed by a set of principles. And these principles are going to provide for data independence, data integrity, and they're also going to reduce data redundancy. So, what is data dependence or independence? Well, if you have a system and the data is too tightly the data is too tightly tied to that application, that would mean the programs cannot adapt to the data changes in data, and they would have to be rewritten. Now, data independence is when you design a database that's independent of the application that it supports. So you can change data in the database without making changes to the application because they're not too closely tied. So databases are primarily used to collect and store data, to update or add data, to retrieve data. You can also analyze and distribute data in databases. Now, as I mentioned, you'll have an application, but when that database is independent of the application, it would look similar to this image here. So what would happen is the application would go off and it would retrieve or add or update the database. When you have a database management system, multiple users can interact with the same database. So it's not restricted to only one user. There are lots of different types of database models. We're going to be looking at the relational database model this semester. But a database model, it shows the logical structure of a database. So a user of a database will just see the data, the tables, the fields, and they'll interact with the data. But behind the scenes, the database is organized into a logical structure. It's not physical, it's not something you can touch. It's the organization of data, the way the data is organized. So a database model shows that logical structure of the database, how the data is organized. The database model also involves the relationships and constraints that determine how the data is going to be stored and accessed. You can think of a constraint as either a limitation or even a rule that your data has to follow. So database models are designed based on the rules the designers adopt. So you can represent a database model, or you can show what one looks like with a database diagram. So as I said, You'll have a logical structure, and that underlying structure of the database is referred to as the model. And they'll have a set of rules that govern the content, the association, and the access of that data. Sometimes you may hear the word metadata. Metadata just means data about data. When you have information about your data, or you collect data about data. So some of the different database models, a flat file is one type, a hierarchical database, a network database, relational database, dimensional database, an object database, and an object relational database. You may, at some point in your career, come in contact with more than one type of database. But it's possible that you may never come in contact with some of these databases, maybe unless you're a database administrator. So a flat file or a file is the most simple type of database model. It's just going to be a flat file that consists of a single two-dimensional table of elements. So you would define a flat file with an application. A hierarchical database arranges the record or the types of records in a hierarchical order. So it's going to be path based, and you'll start at the top and drill down to the next level and to the next level. And these are transaction oriented. They have a one to many relationship. Now, hierarchical databases are more common with legacy systems, older technology. An example of a hierarchical database would be IMS. Another type of database model is a network database. A network database is an extension of hierarchical, but it has metadata. Remember, we said metadata is data about data. And this allows for many to many relationships. You can consider it as a meshed based. So you're not restricted to just one path. You can take uh, just different paths, almost like a network. Then a relational database is going to store data in related tables. We're going to be working with relational databases. So you'll have these different tables. There'll be they'll contain entity sets, and these tables will be related. The, the entity is going to describe, or I'm sorry, the fields are going to describe the entities. And a table will be made up of an entity set. Then you'll have a relational database model. Oh, actually, this is a continuation of the previous slide or the previous database model. So the relationships will exist between record types. And here's an example of what a relational database relationship may look like. So you'll have a customer who may have or order many albums, or they may have many albums in their account, similar to Amazon. If you had an Amazon Music account, you're one customer and you can have many albums. There are also many to many relationships. You can have several albums and several songs. One album contains many songs, and a song can be included on several different albums. And then you can have a one to one relationship. One album will have only one description. So these are entity relationship diagram symbols, and they show cardinality. The crossbar indicates exactly one occurrence, and the crow's foot indicates many, one or more occurrences. Other database model types are dimensional, where you can have relationships that are shown over three or more, demonstrated over three or more dimensions. And object database. So the database would store data as objects, similar to object oriented programming. And then an object relational or object oriented relational database. And that would describe a variety of technologies that combine object oriented and relational concepts. So that's going to end our review or our overview of database models. So I'm just going to scroll through a few more slides. Um, and we'll stop there. Thank you.